Hey y'all, welcome back to Alakazam Math Made Easy. In the last video, we went over trig functions and how those fit into a bunch of other rules that we've already gone over, like product rule and quotient rule, but there's one rule, sorry, we haven't gone over yet, and that's chain rule. And there's a reason why I kept it a little bit separate from product rule and quotient rule, and that's because I wanted to give your brain almost a break before I introduce another complex way of approaching derivatives. And honestly, this is the one that a lot of people generally have issues with comparative to product and quotient rule. But I hope that when I break it down today, it's a little bit clearer because I'm trying to avoid all of the formal math concepts and derivatives and definitions that your professor might be using, right? So what is chain rule? When do we use it, right? We know that we use product rule when there's two things multiplied together. We use quotient rule when two things are divided. But what happens if there's a function that's built into, like inside of another function? Like what if I'm taking a function of a function, right? And that's when we would use chain rule. So let's practice identifying it, right? So we know here that sine is a function, right? But we also know that x squared is a function. If it was x squared times sine x, that would be product rule. If it was x squared divided by sine x, it would be quotient rule, but it's sine of x squared, right? So that's a function of a function where x squared is built inside of sine x, right? So that's why we would need to use chain rule. Same here, 10x squared is its own function that's built inside of e to the x. Again, that's why we would need to use chain rule. What would we use chain rule for here? Because this is a function, but it's multiplied by, it's not inside of cotangent, but it's multiplied to cotangent. Well, this 2x is built inside of that cotangent, right? So that's where we would actually use chain rule. We would use both, right? So this for product rule, this would be our u, this would be our v, but our v would have to be used, or we would have to consider chain rule. So as usual, chain rule can be combined with product rule and quotient rule and other functions that we end up using later on down the line, right? So it is combinable like the other rules. And then lastly, this one here is 7x cubed, and that's its own function, right? That's a straight line, but that's built inside of x squared, right? So in this case, you would have two options, right? You can either FOIL that out and spend time doing that, or you could use chain rule. And my recommendation would be to use chain rule because it'll save you time and it'll save you risk of errors, right? So that's the benefit of using chain rule over foiling. But like I said, it is technically possible to do both. So now we know when to use it, but first of all, how do we use it? So like I said, I'm trying to avoid the super formal language or the formal way of writing these rules, especially chain rule, because it's one of the trickier ones, right? But this is the way it's formally written, right? So by definition, you use it if you have a function g of x built inside of another function f of x, right? And in that case, you would take the derivative by taking the derivative of the outside function, and you would leave the inner part alone, the part that's built into the function, that would be left alone. And then you multiply it by the derivative of the part that's built in. So first you do it in two steps. You leave the inside piece alone and only take the derivative of the outside. And then you multiply it by only the inside piece. So let's use that as an example. I wrote it here in like words because a lot of times people hear that better, right? In English, if you have a function g of x inside another function f of x, take the derivative of the outside function f of x like normal and leave the inside function g of x alone, like don't change it, and then multiply the derivative that you found before times the derivative of the inside function g of x. So again, that was crazy worded, but let's go through some examples, right? So we have sine of x squared. That's one that we identified before as needing chain rule, right? Because x squared is its own function and it's built inside of the sine function. And that's what I broke down here is we know that by that formula, we have to have some function f of another function g of x. And so that's where I broke it down there. So f itself is sine of x, right? There's f. And g of x is the inside part, which is x squared. So this is the part I would practice first, right? Breaking it down into the two components, because if you can get this far, you can pretty much get through the rest of the problem. This is the piece that a lot of people have trouble with, especially in the beginning. So now we've broken it down. Let's plug it into the actual function. So like I said, the first step is to take the derivative of f, right? And here, f is sine of x. So the derivative of sine is cosine. And we're going to leave everything else alone. Whatever's inside sine, we don't care. We're just going to find the derivative of sine and move on to the next step. And then what we're going to do is we're going to find g prime of whatever's in there, right? So g prime is the derivative of g, which is x squared. So the derivative of x squared is 2x. So that's where this 2x came from. So again, we'll combine it. So we're going to leave 2x times cosine x squared as our derivative. So this is going to be our final answer after we've done chain rule. So again, moving on to this next example, let's identify our f and g, right? F is this outside piece. So it's going to be x squared. G is going to be this inside piece. So that's going to be 7x plus 3. So what is the derivative of x squared? That's just 2 times x. So that's going to be our original part. What's the derivative of 7x plus 3? That's just 7. So we're just going to leave that how it is, simplify, and we get our final answer of 14 times the quantity 7x plus 3. The next example, again, let's practice finding f. F is e to the x. G is the part that's shoved into e to the x, so that's going to be the 10x plus 2. Finding the derivative of f of x, e to the x, the derivative of e to the x is just e to the x, so we leave e to the whatever was there when we started. And then looking at the derivative of 10x plus 2, that's just 10. So then we simplify and we get this function right here. So remember I said that we can combine product rule with chain rule, which is one that I want to go over together. So remember, first of all, we should know that it's product rule because we see this piece here multiplied by this piece here. So that's going to be our u. This is going to be our v. But we know that this piece, cotangent of 2x, is not just a normal function. I couldn't find cotangent of 2x on a flashcard, right? So our outside function is going to be this cotangent piece, and the inside function, our g of x, is going to be this 2x piece. So let's embed chain rule into product rule. So remember, for product rule, we're looking at u prime. Let me write this in orange because that's a function, right? So y prime is the derivative of the first function times the second function plus the first function left alone times the derivative of the second function. And this is supposed to be a v. That's my bad. Just like that. But remember, our v prime, this is going to be the step where we have to do chain rule, because our v, what we called our v in the original function here, is the part that has that chain rule embedded. So let's just work through this. So u prime of x is the derivative of 10x, that's just 10. And we're going to leave the second piece alone, cotangent of 2x, plus u of x left alone, that's 10x, times, this is where we do our chain rule, right? So remember, chain rule, we take the derivative of the outside function only. So that's negative cosecant squared of the inside piece left alone. So we're going to pretend like that's just an x. And then we multiply by the inside, the derivative of the inside piece. So the derivative of 2x is just 2. So now what we'll do is we'll simplify this whole thing. So we have 10 cotangent of 2x plus 10x. I'm sorry, 20x, because we have that 2 over there. So we have 20x. We're going to subtract instead of add because it's a negative cosecant. 10x cosecant squared of 2x. And I mean, if we wanted to, we could pull out the 10. So y prime is 10 times cotangent of 2x minus 2 cosecant squared 2x. Beautiful. And as a quick side note, you can't factor out this 2x because those are built into those trig functions. So it's not like it's being multiplied through everything. It's actually inside of that trig function, so you can't factor it out. Another nuance I wanted to go over is what happens if there's a double chain rule. Like just like how there can be a double product rule, there can be a double chain rule. So let me look at this. So we'll do this, sine squared of 10x plus 3. And that might not necessarily look like a chain rule, a double chain rule, but if you write it like this, remember anytime you have a sine squared and then the argument, it's actually written like this. So it's sine of 10x plus 3 squared. So now what we actually have is we have 3 functions, right? So the outside function, the one that is happening over everything else, is the squared. So we have f of x is x squared. And then the next function in is this sine piece, right? Because I'm doing sine of something, right? So our g of x is going to be sine x. And then the last piece is this 10x plus 3. So we'll call it h of x. So remember when we do chain rule, our derivative is the outside function, the derivative of the outside function with everything else left alone, times the derivative of the inside function. Well, that's the same thing. If we do that over and over again, that's the same thing as saying f prime of g of x, but instead of just being g of x, now we have g of h of x times, so now we've taken the derivative of the f piece, so now we peel that off. So now we have g of h of x to deal with, so we take the derivative of g left alone, but now we've considered the function g of x, we've taken the derivative of that, so we can peel that off, and then we're just left with our h of x. So think of it almost like you're peeling an onion or a banana or something. You start with the outside layer, then peel it off. And then by peeling it off, you take the derivative of it. So let's jump into actually solving this, right? So y prime, we're going to start with f prime because that's our outside piece. So what's our f prime is x squared. So the derivative of x squared is 2 times x. So instead of doing 2 times x, I'm going to do 2 times g of h of x, which is everything else inside of our x squared. And we're just going to leave that exactly how it is. And then now I've taken care of this x squared. So I'm going to move on to the next piece, but remember we multiply. So now I have sine of x, right? So what's the derivative of sine x? That's cosine x. But instead of doing cosine of x, I'm actually doing cosine of this, right? So we're going to leave that exactly how it is. And then lastly, now I've done this g of x part. Now the last thing I have to consider is this h of x. And then doing that, I take the derivative of 10x plus 3, that's just 10. So now I've taken the derivative of that as well. So now we simplify. We have 2 times 10 is 20 times cosine, we'll just do it in order. We'll do sine of 10x plus 3 times cosine of 10x plus 3. And that actually can't be simplified any further because, like I said, even though there's a 10x plus 3 in common, that's not being multiplied through. That's actually the argument. It's called the argument of those trig functions. So chain rule is definitely the one that people generally have the most problems with, mostly because of the issues finding what f and g of x are, and even extending that past that, finding what F, G, H, I, whatever, however many segments of this chain rule you have. The hardest part is usually finding the components. So my recommendation would be is think of it like you're peeling off pieces of the function to get to what's in the middle, right? So like I said, to get to the middle of this function, we had to first peel off the squared. So that was our outermost piece. So that's our f of x. And then we had to peel out our sine because that's wrapping something. So that's our g of x. And then the last piece was this piece in the middle. It's not combining anything. It's not wrapping something. So that's our h of x. So if you have questions still, leave them in the comments. But if you've learned something from this video, please like it. If you want to keep up to date with the new videos that I add to the channel, subscribe and press the notifications button. And as always, best of luck.